Good morning, dear students. So, we have completed chapter 3, matrices, and now we come to the fourth chapter, determinants. Now, I hope you remember in a matrix, there can be a rectangular matrix as well as a square matrix. But what is a difference between a matrix and a determinant? First of all, let us analyze what is matrix. Matrix means it is an arrangement of data. Arrangement of data in rows and columns. In rows and columns. This is a square matrix. B is equal to set matrix 1, minus 2, 0, 4, 2, 3. This is a matrix of order 2 rows and 3 columns. Okay. So, we are just recollecting what we have studied in matrix. That means matrix is an arrangement of data. We cannot find a particular value, but we can arrange the data in terms of rows and columns. But in a matrix, there can be a rectangular matrix or it can be a square matrix. Now, what is a determinant? Determinant always correlates with square matrices. Determinant always correlates with the square matrices. And determinant of a matrix, that means determinant of a matrix, that means it will imply it is a square matrix. It can be of order 2 or it can be of order 3, 4, etc. But for your level, we consider only up to order 3. You have to, it is applicable only for square matrices. So, determinant of the matrix A. Determinant of the matrix A denoted by determinant of A, or it is also denoted by determinant of A, or it is also denoted by determinant of the matrix A. Now, when you consider determinant, it is having a finite value. What will be the finite value? So, I am going to consider determinant of A is equal to, you will write it as determinant 1, 2, 3, 2. What is the value of this determinant? The value of this determinant is equal to, you multiply 1 into 2 first. 1 into 2 minus 3 into 2. That is equal to 2 minus 6, which is equal to minus 4. That means determinant is a finite value. Determinant is having a finite value, whereas a matrix is a system of arrangement of data in terms of rows and columns. Now, let us consider one more example. Determinant of A. Determinant of matrix C is equal to determinant 4, 2, 9, 20. What will be the value of this determinant? It is equal to 4 into 2 is equal to 80 minus 9 into 2 is equal to 18. And that is equal to 2, 7, 6. It is equal to 62. So, that means when you find the value of the determinant, it can be a positive number, it can be a negative number, sometimes it can be 0 or it can be a complex number. So, this is what you called as a determinant. Now, here all these examples I have taken for determinant of order 2. Now, we will go for determinant of order 3. What will be the value of the determinant if the matrix is of order 3? Let us consider a simple example. A matrix is equal to 1, 2, 3, 4, 1, 0, 3, minus 2, 6. Now, I am going to find the value of this determinant A, and all of you know this is a matrix of order 3 by 3. What is the value of this determinant? Determinant of A. Determinant of A is equal to, I am expanding along the first row. I am expanding along the first row. That means you can expand either with the first row, second row, third row, or in the same way you can expand along first column, second column, third column, and so on. Now, if I expand along the first row, what will be the value of the determinant? I'll take the first value, 1 into determinant. I'll eliminate the elements in the first row and the first column. I eliminate the elements in the first row and the first column. So, what is the remaining determinant? 1, 0, minus 2, 6. Okay, then at once put a negative sign. Minus 2 into determinant. Minus 2 into determinant. You eliminate the second row, the first row and the second column. First row and the second column. So, you get the determinant 4, 0, 3, 6. I hope you are along with me. And then comes the third value, plus 3 into determinant. You eliminate the first row and the third column. What is the determinant? 4, 1, 3, negative 2. And all of you know how to find the value of a second order determinant. It is equal to 1 into 6 minus 0 into minus 2 is 0. Minus 2 into 4 6 are 24 minus 0 plus 3 into minus 8 minus 3, which is equal to 1 into 6 minus 2 into 24 plus 3 into minus 24. Not minus 24, minus 11 is equal to 6 minus 48 minus 33. Okay, minus 48, that is equal to 6 minus 48 minus 33. 11, 4, 5 plus 3, 81, and that is equal to minus 76. So, finally you are getting a finite value which can be positive or negative. Positive or negative.
Alternate signs.
Now, when you consider this 3 by 3 matrix, just go to the beginning. That is, I am expanding along the first row. Along the first row, 1 into, take the sign as such, 1 into determinant, eliminate the row and the column, 1, 0, minus 2, 6. Then, the next one will be minus 2 into, eliminate the first row and the second column, 4, 0, 3, 6. Then, the alternate sign, plus 3 into, eliminate the first row and the third column, 4, 1, 3, minus 2. And now you are finding the value of the second order determinant. So, this is how you get the value of a third order determinant. As I said in the earlier class, the value of the determinant can be positive, negative, 0 or a complex number. Now, let us consider one more example. Let us consider a B matrix. Let us consider a B matrix. B matrix is equal to matrix minus 1, minus 2, 4, 3, 2, 5, 2, 1, 6. Third order. What is the value of this determinant? So, I will write determinant of B. I am going to expand along the first row. So, what will be the first row? Take the first element, minus 1 into determinant, eliminate the row and the column. 2, 5, 1, 6. Now, what is the sign? Yes, minus. Minus. Then comes the element. What is the element? Minus 2 into determinant. Eliminate the first row and the second column. It will be 3, 5, 2, 6. Then what is the next sign? Plus 4 into determinant. First row and the third column you are eliminating. 3, 2, 2, 1. Okay. So whatever be the sign over here, the second one will be first sign plus, minus, plus. So you have to remember, like when you are expanding a determinant, the expansion sign will be positive, negative, positive, negative, positive, negative. In an alternate form, it goes from positive to negative, which is equal to minus 1 into 2, 6 are 12, minus 5 into 1, 5. Minus of minus, plus 2 into 3, 6 are 18, minus 2, 5s are 10, plus 4 into 3 into 1, 3, minus 4, which is equal to minus 1 into 7, plus 2 into 18 minus 10 is 8, plus 4 into minus 1, which is equal to minus 7 plus 16 minus 4. So minus 7 and minus 4 is minus 11. Minus 11 plus 16 is equal to 5. Is equal to 5. So you are getting a positive value. This is how you expand a third order determinant. Now, using this, you may be asked some questions, like one word answer questions. Write along with me. Evaluate. Evaluate. Evaluate means find the value of the determinant x, x plus 1, x minus 1, x. The question is find the value of this determinant. Okay. What is the value of this determinant? X into x. It is equal to x squared minus. What about the next one? X plus 1 into x minus 1 within square bracket, because there are two terms, or that is x squared minus x plus 1 into x minus 1 is x squared minus 1. Open the bracket, x squared minus x squared, minus of minus plus. So this and this cancel, it is equal to 1. So these types of questions are very important because you will get like one word answer questions. Now some more questions I am giving you. Find the value of x. Find the value of x. Next question. Find the value of x if determinant 2, 4, 5, 1 is equal to determinant 2x, 4, 6x. Don't get confused because it is a determinant, not a matrix. Determinant means it will have a definite value, while matrix means it is just an arrangement of data. So what is the value of the determinant on the LHS? 2 into 1 is 2, minus 5 into 4 is 20, is equal to here. What is the value? 2x into x is 2x squared minus 24. The question is you have to find the value of x. Okay, 2 minus 20 minus 18 is equal to 2x squared minus 24, or minus 18 plus 24 is equal to 2x squared. 6 is equal to 2x squared, or x squared is equal to 3. So what is the value of x is equal to plus or minus root 3. Isn't it? X is equal to plus or minus root 3. Now, these type of questions are also important. When you open your textbook, you can see the questions 4.1. You can do all the questions in 4.1 because they are very easy questions. So, I am leaving exercise 4.1 as homework for you, assignment for you. Now, Next concept is properties of determinants. Properties of determinants. These properties I'll just explain because I know that all of you are having textbooks. Besides, I am giving you notes also. So, you can refer the notes afterwards. Let us first explain what is the property of the determinants. First one, value of a determinant remains unchanged. Value of a determinant remains unchanged if its rows and columns are interchanged. Rows and columns interchanged. That means when you have a determinant 2, 3, 4, 1, 2, 6, 4, 2, 1. I am not going to do it in detail. You can find the value of this determinant. This value of the determinant, or let us consider this one. 2 into 2 minus 12 minus 3 into 1 minus 24 plus 4 into 2 minus 8 is equal to 2 into minus 10 minus 3 into minus 23 plus 4 into minus 6. Minus 20 minus into minus plus 9, 69 plus minus 24. That is minus 44 plus 69 is equal to 5, 25. The property says that if you interchange the rows and columns, if you interchange the rows to columns or columns to rows, the value of the determinant remains unchanged. The value of the determinant remains unchanged. The value will remain as 25 itself. The second property is, because all the notes are given in detail, if you don't have the text, don't get upset because notes is provided. You can take down the notes. If any two rows or columns of a determinant are interchanged, then the signs gets interchanged. If any two rows or columns are interchanged, that means the first row becomes the second row becomes the first row. If these two rows are interchanged or if these two columns are interchanged, what will happen? The value of the determinant, the sign changes. If one value is positive, the other value will be negative and so on. Third one, if any two rows or columns of a determinant are identical, what is mean by identical? All corresponding elements are same. Value of the determinant is equal to 0. That means if you have a determinant 2, 4, 6, minus 1, 3, 2, 2, 4, 6. You can expand this determinant and get the value. But instead of that, here you can see that these two rows are identical. These two rows are identical. That means the value of the determinant is equal to 0. No need to expand, but at once you can say that the value of the determinant is equal to 0. These properties are used to find the solutions for each of the questions. If each element of a row, next one, if each element of a row or column of a determinant is multiplied by a constant k, then the value gets multiplied by k. For the time being, we'll stop because four properties, again 4 more properties are there. We'll discuss, just go through the properties. Thank you.